Hydrogen bonding. Hydrogen bonding is the strong attraction between a hydrogen atom bonded to a highly electronegative atom in one molecule and a highly electronegative atom in another molecule. So this is a intermolecular bond. This is an intermolecular bond that happens between molecules. This means between molecules. So that we've been talking about intramolecular bonds, which involve valence electrons and making things stable. Here we're talking the interactions between molecules that count as bonding as well. This is a special type of dipole-dipole interaction. And let's talk about dipole-dipole interactions because of the polar bonds that are formed when you have the strong electronegative atom with hydrogen and the other highly electronegative atom. So let's take for example H2O, which is a great example of the different types of strong attractions that can happen. So O and H, N and H, and F and H are all good examples of strong attractions and bonds that could produce hydrogen bonding. So let's take just the OH connection we have in oxygen. So I'm going to draw the Lewis dot structure that tells me the shape of the atom, and it's important of the molecule because it's important to show this so we can understand the dipole interaction. So this is going to be a dipole because oxygen is more electronegative. That means it pulls more negative things towards it. It pulls more electrons towards it. And the hydrogens don't really mind. So this side is more negative and this side is going to be more positive, and so making it polar. At times oxygen is going to be more negative and at times hydrogen is going to be more negative. So a cool trick to try to test this out, which we call the polarity of water, is to rub a balloon and you'll get static electricity and you put it right next to running water and you'll see that either the water goes away or comes towards the balloon because of the electricity. It has a charge, a minor charge, and that's what pulls or attracts the water. And so this dipole-dipole interaction allows for connection. So this OH here, this H is going to be attracted. The slightly positive H of H2O is going to be attracted, and we usually draw this with 3 dots. So I'm going to draw it with 3 dots. Shows a connection between this H, which is the one that the hydrogen atom bonded to a highly electronegative atom, which is this OH connection right here, and then the highly other electronegative atom, which is this O, which is negative. So this is a negative and this is a positive connection, and that attraction, it's weak because it's not always on, but its attraction is there. This type of bonding gives liquids and other water specific properties that we can use, and we're going to talk about which ones, the 3 different properties that are going to be part of discussing why hydrogen bonding is really important. So cohesion, which is a property of some liquids, is that they have intermolecular attraction between the like molecules. So if they have molecules that are alike, they attract each other and will pull each other up. So water is a good example of that, because if you notice when you put water together and you move let's say 2 drops of water together, they combine very quickly because they are attracted to each other. There's intermolecular attraction. So this is between like molecules. Adhesion is the attraction between unlike molecules. So think of adhesion or adhesives, which helps me remember because that's kind of like tape. So those are unlike things. Tape is different from whatever you're taping it to most of the time. So the attraction is between unlike things. So adhesion is a property of liquids that they stick or attracted to unlike molecules. So things that are not like themselves. And lastly, we have surface tension, the amount of energy that's required to stretch or increase the surface of liquid by a unit area. This is kind of confusing, but think of if you've seen water in a pool, or you have dove in and maybe had a belly flop and it hurt. It's because the surface tension of water is very high due to the hydrogen bonding, and it's hard to break through the water. It's not really that hard, but when you hit your belly when you jump into a pool or the ocean, it hurts because the surface tension is higher, and there's what we call a skin on top of the water. So there's like a skin here, and sometimes animals can just skim across the top. It looks like they're walking on the water. Some animals called water striders, they can skim across the top because they never break through the water because of this surface tension skin that's produced. So hydrogen bonding, remember, is intermolecular bonding between molecules. Happens usually with OH, NH, and FH connections when they have a dipole-dipole interaction, like this, when this H from one molecule is attracted to the oxygen of another molecule because of the dipole that's created due to the electronegativities of the atoms involved.